well, let's go ahead and look at number 12, least common multiple. All right, you look at your numbers and you think about what is, if you think about multiples, you've got 9, 18, 27, 36, right? Multiples would be 12, 24, 36. Did you hear it? What do they have in common? 36. So you can do it like that. If the numbers are really huge, it might be easier to factor both of them. So if you factored them, 9 would be 3 times 3, and 12 ends up being 3 times, what? 2 times 2 times 3? I think if you did a factor tree, okay? And so then you would have to have, their common multiple would be 2 squared times 3. 2 times, oh wait, no, I did that wrong, didn't I? What is it for their common multiple? It is, 3 times 3 is 9, 2 times 2 is 4 times 3. That's right. Okay. So it ends up being 36 is their least common multiple. And then you end up with, for the variables, you just do the highest power of each one. I think on the test, the problem was, let me finish writing that. The problem was the numbers, not the variables. I want to say, I think I remember that everybody got the variable ones right, but it was the number that they were having trouble with. So I just wanted to show y'all, it's the same as least common multiple that you've always had, okay? And you can just list the multiples. And see what their least common multiple is. Okay, maybe some people were getting that confused with factor, I'm not sure. All right, with this one, I think about half got it and half didn't, and that's fine, but I think maybe you're making it a little harder than what it needs to be. And one of y'all may have a shorter way of thinking about it. If you do, mention it, and that's fine. All right, so the way I thought about this one, I brought my negative down. I said that if this has a negative exponent, it's the same as flipping it up into the numerator with a positive exponent. And if you flip it into the numerator, there's nothing left in the denominator but a 1, right? So it gets rid of the fraction. So that's that negative, and then this negative, and then this is going to be negative 5 squared, okay? And then minus, what's the cube root of 64? 4, because 4 times 4 is 16, times 4 is 64, okay? And then I can work this out. What would I do first to work this out?
Negative 5 to the second.
Yeah, you have to do the power first. I've seen a lot of people try to get rid of the signs first. Don't do that first. I would deal with the power first, okay? Negative 5 squared is going to be positive 25 because the negative is squared also. Then if we take the opposite of that and then the opposite of that, it's still going to be positive 25. Minus 4, which is 21. Okay, did anybody have a different way of looking at that one? A shorter way, or? I think some people, it took several steps to get there, which is totally fine. You still get it right. But I thought it may help if we did that one so that you could look and see that it's not as hard, maybe, as what you initially thought. Okay, so these are the test ones. I just handed the test back. If you scanned and emailed me a test, then I graded it and sent it back to your parents. So you can get it from them. But if you turn in a physical copy, I handed you back a physical copy. Okay, I think this first lesson, we would be better at looking in your book because I'm not really good at drawing right triangular prisms. How about y'all? Okay, so let's just look at them in the book. I don't think this is going to be an issue, and really some of the second lesson is going to be easier to look at. So go to page 242. 242. And I think part of the point of this lesson is making sure you know the names of the three-dimensional figures. And basically, they're going to be named by their base, okay? So like the first one you see at the bottom of 242, it is a triangular prism because the bases are triangles. What other shape do you see that makes up a triangular prism?
A rectangle?
Yeah, there's rectangles. So do you see there's 3 rectangles and 2 triangles? So how do you decide which ones are the bases? Why isn't this a rectangular prism if there's rectangles? It's a good question. How do you know?
The bases are parallel.
That's it. Good job, Laurel. So the bases need to be parallel to each other. So you look at it and you say, okay, I see rectangles, but the triangular sides or faces are parallel to each other. So that's what you name it after. Okay, so it's a triangular prism. And then there's a right circular cylinder. A cylinder is going to be something with circles, okay, parallel circles. Then you've got a pyramid. What determines a pyramid? Why isn't that I don't know, some other kind of prism?
There's no top.
Yeah, there's no top. It goes to a point, okay? So you can have a triangular pyramid, you can have an octagonal pyramid, you can have all kinds of pyramids. But that's a regular square pyramid. All right, what's the word regular mean? You know? All sides equal. Okay, so regular. A regular rectangle is also known as a what? Think of a rectangular, a regular rectangle. I could say the word rectangle. A regular rectangle would be a square because that's a rectangle with all sides equal. All right, and then you've got a sphere on the end. All right, I'm gonna look at the next page. It's talking about prisms and cylinders, and it gets into what we're talking about, the bases being parallel to each other. And you'll just have to read through those, lots of different vocabulary, you'll see it, you'll be fine, okay? If it tells you if it's a right cylinder or a right prism, that means it's perpendicular, okay? It's also perpendicular, 90-degree angle, it's not slanted, okay? The part that I wanted to point out, there's two things that I thought were a little bit tricky. On page 244, y'all see 244? Turn over the page. There's, the first box there says volume of prisms and cylinders, okay? The volume of a prism or a cylinder is equal to the area of the base times the height. So they're just giving you a shortcut, and they're giving you a formula that will work for any type of figure that you have. You find the area of the base, multiply it times the height. So look at their example 1. Y'all see that? 60.1? Put your finger on it. Show me you know where we're at. All right, good. All right, with that one, they give you the area of the base. What is it? 28 square centimeters. And then they tell you the length of the side is 10. So all you have to do is multiply those two. There isn't any more work. So the reason I'm pointing this out is when you do your homework, you may think, oh great, it's one of those, okay? But these are the good ones to have because there's not going to be a lot of work. A lot of times they're going to give you the area of the base. All right, the other thing I wanted to point out is lateral surface area. Look down at the bottom box on that page. This is different. This is not regular surface area. Lateral surface area is, and actually above the box, it tells you. Look above the box. We define the lateral surface area of a prism or a cylinder to be the area of all external surfaces except what? The bases. Okay, so I thought we might need a visual for this. And when I looked on the very top of the trash can, yes, I did grab this out of the trash. There's nothing on it, so I think we're okay. Y'all don't have to touch it. But on the very top of the trash, my husband had gotten this package. And I thought, oh, that'd be perfect, okay? So when it's talking about lateral surface area, normally for surface area, we had to find the area of the top and the bottom and all the sides and add them together, right? But lateral surface area is saying that it's just the sides and not the bases, okay? You see? Now this particular rectangular prism could be, these are the bases, or I could view it like these are the bases, or I could view it like these are the bases, right? And that's fine. But for other ones that you're doing, it'll be obvious which ones are bases. For example, if you look on that page, it says it's a pentagonal prism, so it's a pentagon, top and bottom. Okay, but key thing to remember here, lateral surface area, look at the box. Isaac, will you read that sentence at the bottom of the box, the lateral surface area?
244.
Yeah.
The lateral surface area of a right prism or a right cylinder is equal to the perimeter of a base times the height.
Okay, so catch that. That's actually a pretty easy formula. It's the perimeter of the base. So perimeter, watch what I'm outlining here. From here all the way around, it's the perimeter times the height. You're not going to have to find the area of the top and bottom. You just need to find the perimeter and then multiply it times the height for the lateral surface area. Does that make sense? Okay, so it's different. So if you look on 245, an example of this is at the top. Find the lateral surface area of this right prism, meaning all sides are equal on the base, whose bases are what? What does it say the bases are? Regular pentagon. So I think I just said that backwards a second ago. Let me write it and get it correct here. Regular is all sides equal, okay? Right is talking about it's perpendicular, it's leaning. It's not leaning. Oh my goodness, I keep messing that up. It is not leaning, okay? So you're not talking about like a leaning tower of Pisa or something, okay? It's not that. If it's right, it's like straight up and down, so 90 degree, okay? And regular just means that the base, whatever shape the base is, it's going to be equal all the way, all the sides, okay? So if you look at how they do that one on 245, they're basically cutting it apart, okay? And they're showing that you can unwrap that. We've talked about that before. But for this one I'm holding in my hand, if I told you that this was, each of these sides were 3, look up here. If I said these are 3, I'll write it on the box since I can throw the box away anyway. I'm just going to say that's 3 inches right there, okay? And then I'm going to say that the top of the whole thing is, to make it easy numbers, we'll go with 10. Not to scale, okay? We got 3 inches here and we got 10 here. If I wanted lateral surface area for this one, they just told me my formula is what? What did Isaac say? Y'all okay?
Perimeter times the height.
Perimeter times the height. So what's my height? That's the easiest part. 10. 10's my height. And then my perimeter of the top. What's my perimeter going to be?
3 times 4, 12.
Where'd you get 4?
4 sides.
Yeah, there's 4 sides. So 3 fours is 12, and then 12 times 10. Why are we finding this perimeter? Well, it's imagine if you cut it and unwrap it and made one big rectangle out of this. So you're finding just the area of the sides. Okay. Y'all are making the faces that mean either, oh, we so get this and you can just move on, or we have no idea what you're talking about. Unfortunately, it's the same face, so I don't know which one it is right now. Like, if you really get it and you're like, we got this, give me a thumbs up. If you're like, I have no idea what's happening, you can give, okay, good. There we go. All right, we will move on. I don't feel like it's necessary to draw those, because the pictures in the book are going to be much better than what I can do up here on the board. Y'all already know I can't draw. All right, let's go to the second lesson, which will have some things for you to write, but not yet. We'll keep looking in the book for a second, because I think it'll be easier to see if we look at it here. All right, on 247, so turn the page over. 247. Okay, do you see their set B? What's in their set B? It says B 1 and 2. Okay, 1 and 2 is in set B. What's in set A?
1, 2, and 3.
1, 2, and 3. Okay, look under the next sentence under it. It says we can say that set B is a subset of set A, because all the members of set B are also members of set A, okay? So you can kind of think about this as like a family, okay? In our family, we have my husband's parents, the Hills, that we call Pop and Grandma, okay? That's a set, okay? My husband was born into that family, so our family is kind of a subset of that. And all of our boys. We are a subset of that because we are also Hills that are in that set as well. Does that kind of make sense? Okay, so if you look at those numbers, what they use to denote that is they use that little sideways U. They said that B is a subset of A. Okay? What if I did that? What would that mean?
No.
Not. B is not a subset of A. Okay? And then it gives you some other examples. I want to get over to, I think it'll make more sense on page 248 if we look through the examples there. And again, I'm not going to write those out. We're going to have some other stuff we need to write in a bit, but not just yet. All right, 61-1 on page 248. Do you see set D? Actually, yeah, let's write this out. Okay, here we go. This is lesson 61, and this is example 1. And let's just write them so we can see what they are. Set D. Again, remember how you draw your little sets with the braces? Okay? D is 0, 1, and 2. E is, okay, they did 1, 2, 3, ... And G is 1, 3, and 5. Two of those are finite sets we talked about last week. Which two are finite?
DG.
D and G, because there's only a certain number in there, right? Which one's infinite? E. How do you know, Kate?
It has a little dot.
Yeah, it's got the dots. It says it just keeps on going forever, okay? I'm going to write some statements up here. The answers are in your book, but we're going to talk about them, so you don't have to look in your book unless you just want to. This means E is a subset of G. E is a subset of G. Is that true? Is all of E included in G? That's not true, is it? Okay? Because this has a lot more in it, doesn't it? So we would say that's false. All right, let's look at B. B says G is a subset of E. Look and see if that's true. G is a subset of E. Is all of G in E? Yeah, so it's true. All right, good. And then C, it says D is a subset of E. Or is all of D in E? No? No? Why not?
No, sir.
No, 0. Very good. So it's false. Okay. Does that sort of make sense? Okay. Now, you'll use that for some more things later. This is kind of just the introduction to it. And you know how Saxon does. We'll give you one little piece and let you get that, and then we'll add another piece later. So that's the piece for today. All right, the next part in your book is something that I thought we actually had been over, but maybe I'm losing it. Maybe we only did part of the number system. I do want you to draw this in your notebook, okay? You ready? You can do boxes, you can do circles, but it's gonna get big, so I suggest you're gonna need probably half sheet of paper or more to do what we're doing, so you may wanna start on another sheet, whatever. But I'm gonna start kind of in the middle and work my way out. You can draw a box that's natural numbers, okay? We also call these counting numbers. What do you think they are? Start counting. Where do you start? Yeah, you always start at 1, right? Didn't we talk about this before? I thought we did.
I brought it up in my book first.
Oh, okay. Yeah, and so number of sets, names of sets, it's important because they're going to say, give me an integer, and if you know what an integer is, then that's going to be problematic. All right, let's do another box just a little bit bigger than that. And we're going to put the whole numbers in it. What are the whole numbers?
It includes 0.
It does include 0. So it's just the natural numbers plus 0. Okay, so it's just going to be 0, 1, 2, 3, ... Okay? What I think of when I do this, and maybe this is me being silly, but here's me. There's Lucille. I live in Rutledge. Okay? Rutledge is in Morgan County. Morgan County is in Georgia. Where's Georgia?
Yes.
United States. What could I do here?
Continent.
Oh yeah, I was thinking North America. Okay, we can just keep going. What would we do next? We're gonna do Western Hemisphere or Earth. What did we just do? Earth. But I can keep going.
Solar system.
Okay, I can do the solar system, galaxy, whatever. So I am in Rutledge, which is also in Morgan County, which is also in all these things. But are all people who live in Morgan County in Rutledge? No. So that's how the nesting diagram works, and it's the way it works with this too. I'm just using squares because it's easier, or rectangles because it's easier to draw. All right. Do what?
We got that like thing a lot in CC.
Oh, you do a bunch of Venn diagrams?
We did.
Yeah, Venn diagrams are good. That's a great way to organize things. All right, then you've got integers. What are integers?
Including negatives.
Yes, they're going to include the negatives. So it's going to include what's already there, your natural numbers, your 0, and then it's going to include your negatives. So I'm going to put dot, 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 -3, -2, -1, 0, 1, 2, 3, dot, 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 for integers, okay? And then after that, you have your rational numbers. What are the rational numbers?
Anything that can be with a decimal.
Yes, well, pretty much. There are some decimals that aren't rational. There are decimals
most decimals that do not continue forever.
Yes, so decimals that terminate or repeat. So they can go on forever as long as they repeat. Okay, so we're going to say these are things that can be written as a ratio of two integers. So I'm going to say can be written as a ratio. What's a ratio?
Something like 11 to 2.
Yeah, it's a fraction, right? It can be written as a ratio of two integers. As a decimal, it's going to stop, it's going to terminate, or it's going to repeat. Okay, so like, y'all know this fraction. What's it as a decimal?
0.5.
0.5, it stops. What's this as a decimal?
0.3.
0.3 repeating. So as long as it stops or repeats, but technically the definition is it's a ratio of two integers. That's pretty important. So look, is 1 an integer? It's hard to say. Is 1 an integer? It is, isn't it? Is 2 an integer? Yeah. So this is a fraction made out of two integers, a ratio of two integers. So yes, it is a rational number, okay? Ratio of two integers here. So that would kind of mean what doesn't work. What decimal is there that would not work? Well, that's where you add this other box out here off of this box. And what's the opposite of rational? If somebody's in an argument and they just keep going on and you're like, man, you're being irrational. That's these decimals. They just keep going on and on and on and on. If you brought your calculator, this is the only reason I'm asking you to bring it, type in square root of 2. Does it stop or does it repeat? Does it either one of them? It's not going to stop or repeat, is it? Square root of 2. Whoops, I got a bunch of stuff. I let a student use mine yesterday. What's in there? Okay, what'd y'all get? 1.412, 41421356 something like that? So what you got? Okay, that keeps going. It just stopped because your screen is limited, right? So square root of 2 is an irrational number. What about this number? What is this number? Pi. Does it ever repeat? No. Does it ever stop? No. It's an irrational number. Now some teachers have taught you, well, you can use 3.14, but that's rounding it, right? Okay. Some teachers will teach you can use 22/7 as a fraction, and that is a ratio of two integers, but it's a rounded, it's an approximate fraction. It's not exactly equal to pi. If you do 22 divided by 7, you don't get the regular 3.14159, blah, 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 right? Okay, so the next category that we put up here are real numbers. Now, a lot of students, when I teach this, they're like, oh, okay, so that's the end. Well, there's actually not. Now, if I tell you there are more than real numbers, what's that mean this other category is? What would you call it? Fake numbers. That's usually what everybody says. That's fun. Fake numbers. Well, they actually call them imaginary numbers. And that's an Algebra 2 that you learn about imaginary numbers. Okay, and I'll give you a preview of it. It's square roots of negatives. It's all based off of, in some formulas, you have to be able to deal with square roots of negatives. So they define square root of -1 as I. And that is an imaginary number. Okay, that's Algebra 2. All right, so you have to be able to use, not this yet, but you have to be able to use this to answer questions about sets. Okay, so look back in your book on page 250. We are going to write these down. I did want the chart in your notes, but not necessarily these questions, because I think you'll get them. All right, 250, all right? The first one on 250 says 1/2. What's that little E looking thing mean? Is an element of, okay? 1/2 is an element of what sets of the real numbers? Well, is it a natural number? Is 1/2 natural? No. Is it a whole number? No. Is it an integer? No. Is it a rational number? Yes, because it is a ratio of two integers. So you would say it is a rational number and one more.
Real.
Real. Good. Okay. Look at the next one. 5 is an element of which ones? Yell it out. Naturals, wholes, integers, rationals, reals. Okay, look at the next one. 3 square root of 2 is an element of which sets? Any of these? Not any of these, but irrational, right? Is that what you said? Irrational. Yep. All right, so, and that's what it talks about there. And then it uses the, what's the little U? How did they say the U thing is? It's not an element of, I just lost it.
Subset.
Thank you, subset of. Okay, so A says, are the reals a subset of integers? Or it's stating reals are a subset of integers. Are the reals all in the integers? No, the integers are in the reals, right? So you would say false for that. Does that make sense? Okay. All right, well, we won't spend too much time there. We'll get on to the actual math problems. That was all mainly definitions and understanding all that. Now we go to lesson 62. Why don't y'all stand up and stretch? Do you need to walk around, get a drink of water? Anybody need to go to the bathroom? Forgot to go? If you need to. Y'all all right? You're so quiet. Claire, you're gonna have to tell Luke we missed him. Maybe we're normally this quiet, but Luke is usually here. So between Luke and Isaac, they can talk a little bit, and it gets a little louder. All right, this is lesson 62. All right, what is the? You don't have to write this part until we get to the example. What's the square root of 16? 4. How do you know it's 4?
Because 4 times 4 is 16.
Okay, so Laurel says she knows it's 4 because 4 times 4 is 16. Is there another number that when you multiply it times itself, you get 16? There actually is. Negative 4. Why do we always say square root of 16 is 4? Why do we not say plus or minus 4? I don't really know either. We do though. We always assume the positive because that's usually what we're talking about, right? But mathematically, we have to account, do what?
It's not a negative number.
Yeah, we just, I don't know. But the negative times the negative would also give us a positive, but there are some times that we have to account for, there's actually another number that can make that true, and we'll get to those later, but they're gonna start introducing that a little bit today. Okay, the other thing that they try to introduce today is this. If you have the square root of 16, and then you square that, what do you have?
16.
You have 16, right? There are a couple ways you can think of it. Square root of 16 is 4, and 4 squared is 16. Or you can think of it as that square kind of cancels out that square root, and you're just left with the 16, right? So that's another concept that they're kind of kicking out there today. All right, here's your first example. So write this one down, please. I want you to use your calculator to find out the square root of 18 correct to 5 decimal places. So it'll be like the easiest algebra problem you've ever done. No work to show. Just grab your calculator. Square root 18. What'd y'all get?
4.24264.
Okay, and that's 1, 2, 3, 4, 5. Good to me. Did everybody get that? Plus a few more, but we're rounding it to there on the calculator. So Laurel got it, Claire, you got it? Claire, did you get it? No, something weird came up?
I don't, how do this?
Oh, well, that's what I was gonna ask and see. Here you go, so you do, let's see, is it on, oh. It's not looking like it's on. Oh, there it is, I turned it off. I'm sorry. All right, so square, I can't do it, that's square root is the second key, and then the x squared key. See the little tiny blue? And now you've got a square root. So you can just type it under there. Isaac, do you know how to do it on that one? You got it, okay. Kate, how about you? Did you get it on there? No? Can I see? I don't know that calculator, but we can try it. Oh, there it is. It's similar, actually. You're going to hit second and the x squared key. See the tiny little square root? So hit second and then that. And then type in, here you go. Okay? All right, and you don't have one?
We have one of those
Oh,
ones, but Mom can't find it,
Oh, no.
so, yeah.
Well, eventually she'll find it.
Yeah.
And when she does, we'll show you that you can kind of look complicated. Or kind of in between Kate and Claire. All right, so this was the reason I wanted to do this. I wanted to make sure you did know how to get it on your calculator. Okay? All right. Let's see. There goes. What if I asked you to find both square roots of this? What would the other one be?
Negative.
Negative, right? If they ask you to find both, they're just meaning find negative. Okay, the next example, I'm not going to have you write it out, but I want to see how many of y'all on a blank sheet of paper, grab a blank sheet of paper. This is a race. Yeah, just want to see. I don't know them all. I'll be honest, I wouldn't win this one either, but I want to see if anybody does. Luke missed out. Okay, this is a race. You ready, Isaac? Write down the first 20 perfect squares. Try to get all the way. So 1 squared, 2 squared, 3 squared, 4 squared, all the way to 20. Are you ready? Go. No calculator.
Just like
See the ones you know. I know you know 1 squared. All the perfect squares. So it's going to start 1 squared is 1, 2 squared is 4, 3 squared is 9. That's all we'll give you. Keep going. See how many you can get without a calculator. You probably have a lot of them memorized. Was there a song for it? Is that a CC thing?
Yeah.
Yeah.
Does it go all the way to 20?
It goes to 15. What is it? 15? I don't remember.
15.
You have to like remember them. You can't like figure that out.
You can figure it out. I just want to see how
It
many you
goes
have
to
memorized.
15. Oh, okay. That's the best I got. I think I got 2 of them now because I couldn't remember that.
Once you get yours, you can look in your book to see if you got them right, because they're actually listed in your book.
What page?
254.
I go on through 15.
Oh, Isaac's gonna figure out. I think I knew through, I don't know if I even remember 15. I knew it had a 5 at the end, but that's all I got. I know I got it through 13. I don't think I had through 15. Of course, I've got the days I start forgetting everything. Okay. So, Laurel, how many did you get?
I got through 12.
Oh, that's good. Okay.
12.
There's 12. You got 15. Kate, what about you? She's still right.
Okay.
Isaac, how far did you get before you had to count and start working them out?
15.
15? That's good. You should find your CC teacher and tell them that you were still remembering it. That's pretty cool. The book points, the book points out that you really should memorize your perfect squares because they'll help you with some of the problems you're going to be doing. But if you don't, it's okay. Okay? But it was just interesting to see. All right, this next example is example 4. I'm skipping the other one because this one's pretty important that you're going to see. And it's not using your calculator, so do not use your calculator on this one. I want you to estimate the square root of 10. And when I say that, they're going to word it like this. Determine between what 2 consecutive integers this would lie on the number line. So is the answer to this between 1 and 2, between 2 and 3, between 3 and 4, between 4 and 5? What 2 integers would this be between? Okay, without using your calculator. Write down what you think it is, and then we'll talk about it. I would say it's between what and what? What do you think?
3 and 4.
3 and 4. Because 3 squared is 9 and 4 squared is 16. If someone pressed you and said, well, which one's it closer to? Is it closer to 3 or closer to 4? What would you say?
3.
Closer to 3 because 9 is closer to 10. Does that make sense? So you may have some homework problems like this where you're not going to need to use your calculator. It's just asking you to estimate it, okay? Another thing they throw at you in the book, and you don't have to write this part down, it's right there. This is very similar to something we were talking about a minute ago. What would this be?
X.
X. Remember, we can think about it as the cube cancels out the cubed root, right? So it's just x. So this is actually a property that's listed in your book. So let's use something like that for example 5.
I got 20.
You made it. All right, here's A. Write down, no calculator, what's the cubed root of 8? See if you can figure out the cubed root of 8. It is 2. Caroline, did you say that? No, who said that? Oh, Claire? No? Oh, Laurel said, wow, I was way off. All right, it is 2, because 2 cubed is 8. 2 times 2 is 4 times 2 is 8. What's the B is the 4th root of 81. 4th root of 81.
3.
3 times 3 is 9, times 3 is 27, times 3 is 81. So you're not dividing by 4, are you? You're not dividing by 3. You want to know what number times itself. So 2 times 2 times 2 gives me 8. I need 4 of something. 4 of those 3s. 3 times 3 times 3 times 3. A lot of students will try to divide by that number, but you're not dividing by that number. All right, here's a little tricky one. Cubed root of negative 27. Can you have a cubed root of a negative? You can. Yeah. As it says negative 3. 3 times 3 is 9, times 3 is 27. A negative times a negative would be a positive, but times another negative would give me a negative. So when you see a cubed root of a negative, don't say, oh, I can't do that. You can do cubed roots. Can you do 4th roots of negatives? No even root of a negative, you can't, until algebra 2. example 6. Alright, I'm going to copy it just like I copy it. No parentheses in the first one. -2 squared plus, in parentheses, -3 squared plus or minus the square root of 4. Okay, really important to see the difference between parentheses and no parentheses, okay? What does this one simplify to without the parentheses? You actually don't get rid of the negative. This one is, because it's being squared, so it's -3 times -3. But this is like negative and then 2 times 2, or the opposite of 2 times 2. So this one's going to be -4. Okay? And then we're going to bring down plus. I can go ahead and do the next one. -3 times -3 is +9. And then I want you to bring down the plus or minus. What's the square root of 4? 2. Now, they're not telling you this now, but a lot of times in a formula, when you have a radical like that, they'll have a plus or minus because they are trying to take into account that that root could be positive or negative. You don't have to worry about that now. I'm just telling you that's why they're doing it, and you will have to use a plus or minus. They're just trying to make sure you know how to do a plus or minus, okay? So you don't have to know that part, but we can go ahead and simplify that, okay? All right, then we can left to right, -4 plus 9 is +5, and then plus or minus 2. They are too cute. Hey, y'all. They're trying to rescue y'all, you think? 5 plus or minus 2. You're going to get 2 answers, okay? What would it be if it were plus? What's 5 plus 2? 7. What would it be if it were minus?
3.
There's your 2 answers. And the book just wrote it, separated by commas, just like that, I believe. Yes, they did. So that's all it's doing. It's not that difficult, I do not think. And that is all of that lesson. And now we're down to the last lesson. Here we go, lesson 63. All right. There are some things you need to know about roots. And I think I'm just going to try to tell them to you as we do the examples. And you can read the lesson later and see all the rules. Example 1, square root of 50. Now, one important thing to be able to do is use your calculator and find an approximation of it. We've already done that, so this lesson is not that, okay? The other important thing to do is to be able to estimate what this is. What would you estimate this as? It's going to be between what and what? 7 and 8. 7 squared is 49. 8 squared is 64, right? Yes. Okay, so it's going to be between those two. We did that in the last lesson, so that's not what they're wanting, but we could do it, right? We could do that. This lesson, what they're wanting you to do is simplify this by hand, not using the calculator. You're using a calculator, we have to round it, right? Yeah, we have to round it. We're looking at these decimals that don't stop and we have to round it. If we do it by hand and include a radical in our answer, it's actually technically correct without having to round it. So let me show you what I mean. The first thing you do, and the direction will say simplify, okay? The first thing you do is think of the prime factorization of 50. So I'm going to give you a step here. You're going to factor 50, okay? Well, I guess we'll leave it general, but factor the number, okay? So I'm going to take 50 and break it in and do a factor tree. What times what? What are you going to do?
225.
All right, 2 times 25. 2's prime, so I'm going to circle it. What's 25? 5 times 5, and they're prime. So this is, square root of 50 is the same as the square root of 2 times 5 times 5. Okay, so hold up for a second and make sure you follow me. All I did was factor, do the prime factorization of 50, and I I rewrote 50 as 2 times 5 times 5. That's all I did, okay? In the book, in the lesson, they tell you that you can actually break the roots up. That's the same as the square root of 2 times the square root of 5 times the square root of 5. You can actually break up roots like that, okay? If that's the case, what here can you do? What do you see here that you're like, oh, I can do that part? What's this times this?
5.
Yeah. So we can do this part, that's just 5. Square root of 5 times the square root of 5 is just going to be 5. So this is going to be equal to 5 times the square root of 2. Grab your calculator, type in this, and then type in this. Do you get the same answer for both of them? Square root of 50, get an answer. It should be somewhere between 7 and 8. And then type in 5 times the square root of 2. Some of you, your calculator, you may have to do square root of 2 and then times 5. Clear to get it? They're the same?
Yeah.
Alright. Laurel, did you get it? Yep. Kate, did you get it? Almost? Isaac? Okay.
So,
Yeah, and something, did it come out the same?
as
Yeah. Did you type in square root of 50?
No.
No, right, do square root of 50. It should be the same as 5 times the square root of 2. There are gonna be times where it's okay to use your calculator and round it. There are gonna be times that they do not want you to round it. They want it accurate, and then you're gonna have to simplify it like this. Okay, so let's do another one.
It was the same.
It was the same, okay, good. Here's one that you can try to do on your own, and then I'll do it up here. Example 2 is the square root of 147. So you're gonna start by factoring it, okay, and then you're going to, I don't know how I didn't even write that as a step. How would you say that? Factor it. I don't know any other way to say it than simplify. Simplify the root without rounding. So I guess it's like a 2-step thing. Okay? So do a factor tree for 147. And you can use your calculator if you're trying to find factors of 147. I mean, we've got them today, why not use them, right? Shall factor 147. Did you get 3 times 7 times 7? Is that what y'all got? Okay. And then did you break it apart? Square root of 3 times the square root of 7 times the square root of 7? Okay. What can you do there?
Make it 1 second.
Yeah, the square root of 7 times the square root of 7 is just 7. So that's 7 square root of 3. Who got that one? Give me a thumbs up. Did you get it? Good. Close? Yeah? Okay. Alright, good. Alright, let's try another one. So the good thing about the stuff you're gonna have, the new stuff in homework this week, they're not long problems. Have you noticed that? Nothing ginormous this week, so that's a good thing. Alright, this is example, oh, I skipped, that's okay. Example 3, square root of 200. Square root of 200. Alright, did you get that as your factorization? Yeah? Okay, and then if I split them apart, square root of 2 times square root of 2 times square root of 2 times square root of 5 times square root of 5. Is this step absolutely necessary? I don't think it is. You can tell right here, can't you? You can say, look, if this is like 2 times 2, you can pull out a 2. You know that you're gonna, every 2 of them, one's gonna come out. So, right? But if you need to, you can write it out, that's fine. So this is gonna be 2. Now, what do you do since you have a 2 and a 5? Is that 25?
5 times 2.
Yeah, they're times each other. This is times this, times this, times this. So this 2 is times the square root of 2, which is times 5. And then we use our commutative associative properties. 2 times 5 is 10, square root of 2. That's why we end up multiplying those. Okay? Alright, let's do one last one and then I think we're done. Okay, let's see. Example 4. 108. Square root of 108. Was that from memory? You're trying to do it from memory? I don't even know if I could, I think, was it 121? Okay. Oh, yeah, checked it. A different square root number. Oh, yeah, because one of those comes out.
Okay.
One of those comes out. That's gonna be
That's
right.
what.
Yeah, yeah, you're close. What is that? Did you see that? when you get yours, you can check it. Did you get it? Okay, good, good.
I got a 5 in the square root place.
Did I mess up? I could have messed up. Let's see, well, there shouldn't be a 5 in its factorization though, because it doesn't end in a 0 or a 5. Right? Yep, so there must be a 5 in there somewhere.
I put the number 180.
Ah, that's what it is. Okay, good. Alright, so that's how you do those. The last little part of this section is, I'm a little confused because it's acting as if you've never seen a repeating bar. Y'all have used repeat, I mean, that's like an earlier thing, right? So I'm not really sure why there's part of the lesson is on repeating when I feel like you will know that, but anyway. You probably know 1/3. What's 1/3? 0.3 repeating, right? Ninths are repeating. So like 1/9 is 0.1 repeating, 2/9 is 0.2 repeating, right? Y'all probably had a lot of those. I'm not sure why it's saying that. Maybe it's just saying I don't know, maybe it's just saying you should memorize them or whatever. I don't know exactly. But I know you don't know how to handle that. Okay? Alright, so that is it for today. Nothing, this was probably an easier algebra thing, don't you think? So if you've gotten a little behind, I know some of y'all's classes have been doing final exams and stuff. If you've gotten behind, this will be a